Okay, hello everyone. We will be going through the topic of materials today. So there are various sections to this lesson. So do watch this video slowly, and if you do not understand any parts of it, do revisit this video. Okay. So the first part of the lesson would be asking ourselves about the properties of materials. So what do we mean when we are talking about properties of materials? So let's just take a look at it, an explanation over here. So when we are talking about properties, what we are essentially asking is what are the characteristics of something. So for example, we know about the different materials that we use in our everyday lives. For example, wood, metal, plastic. These three materials are not the same. So what about them is different? So that is their characteristics, or what we're talking about here is their properties. So each of these materials have different properties which make them suited to be used for different kinds of objectives. All right, so there are 5 properties that we need to know. So we'll go through them one by one. So the first property is strength. Strength refers to how durable a material is, so how strong it is. In order for us to test strength, we can actually drop the material to see whether it breaks, or we can actually put weight on the material to see the breaking point of the material. An example is using tables that are made out of different materials. For example, a table made out of steel and a table made out of wood. The table made out of steel would definitely be stronger than the one made out of wood, and we can actually test this by seeing how much weight the table can actually undergo before it reaches its breaking point. Okay, so here are just some examples of weak and strong materials. So weak materials are, for example, wooden sticks, cotton, while strong materials are like metal, steel. All right. So as you may be wondering, is wood always a weak material? The answer is no. It depends on what kind of wood you're using or the thickness of the wood. So what I'm trying to tell you here is that materials, it really depends on how you're using the material and what are the properties of the material. For example, thickness, the source of the wood, how long the wood has been used. These are some of the factors that affect the strength of the material. All right, so secondly is flexibility, is whether you can bend it. All right, so flexible materials can be bended, while non-flexible material, when you bend them, they will actually break. So we have 2 examples here, rubber band and ceramic. We can actually test the flexibility of materials through bending them and seeing how far they can bend. So the further the material can bend, it tells us that the material is more elastic. Thirdly is the ability to sink or float. All right, so sinking is basically when you put it in a basin of water, it does not rise to the surface but rather stays at the bottom, while floating is the phenomenon where it rises to the surface. So we have 2 examples here, styrofoam and metal, and we can actually test it by what I mentioned earlier, putting it in a basin of water and observing what happens when you do this to the material. So remember, this is a very important keyword, observe. All right, so when we're doing science, remember, you want to use your scientific vocabulary. For example, observe, examine, analyze. These are some of the good words that you want to use when you are making your answer. So fourth, we have waterproof and non-waterproof. So the definition is that its ability to absorb or not absorb water. So non-waterproof materials include paper, waterproof includes plastic. So in order to test whether something is waterproof or non-waterproof, we can actually dip the material in water and observe whether it absorbs the water or not. For example, cotton, after you dip it in water, it would actually absorb the water, and therefore it is non-waterproof. So number 5, we have transparency, which refers to the amount of light that can pass through the material. We have 3 different degrees of transparency here. Let me just circle it for you. So how you would describe this is degrees of transparency. Alright, so opaque refers to not allowing any light through. Translucent refers to letting some light through. Transparent refers to letting all light through. And the way we test the degree of transparency of a material is to actually take a torch and shine the material and observe the darkness of the shadow which is produced. So now I will just draw for you how the setup will look like in order for you to test the transparency of a material. Alright, so here you have the light source. So this is your torchlight. And then you have your material here. And behind you, you have a wall. Therefore, if after you've shined the light, you will observe whether a shadow is formed on the wall. If there is no shadow, it means that you have a transparent material. If the shadow is not very dark, perhaps you have a translucent material. And if the shadow is very dark, what you have would perhaps be an opaque material. Right? So remember, these are the 5 properties of materials that you need to know. And if someone asks you, I need recommendations on, for example, making cutleries for children. So you would use these 5 properties in order to actually determine what kind of material you want to use. So for example, 1, it has to be strong, it has to be durable, but it also has to be flexible, because it cannot be something that's very stiff, because children might hurt themselves. Therefore, using plastic or using rubber may actually be a very good option for you if you're making children cutleries. Alright, so moving on, we would like to look at the topic of materials and heat. So remember, when we are doing science, a lot of the topics are actually interrelated with each other. So knowing the topic and how they link to each other would definitely help you in preparing yourself for your examinations. So we are going to talk about materials and heat. So some of you may be wondering, what is the link between materials and heat? So as you may have learned, when we are talking about materials and heat, you may hear some words such as conductors, insulators, and these can be properties of the material. Alright, so let's go through these 2 terms that I've just mentioned, conductors and insulators. What are they and what do they do? Alright, this will be a very important question that we will address. Alright, so from the other video which talks about heat, we know that heat is a form of energy, and it moves from warmer objects to cooler objects. Alright, so over here we have the heat from the hand, and it is moving to the ice. So the ice is gaining heat from the hand. The ice is gaining heat from the hand. Since the heat from the hand is transferred to the ice, the hand actually loses some heat. So the hand is losing heat to the ice. So these are very important words to remember when we are doing heat. So 2 words to remember is gain heat, lose heat. Please remember this because it is very important when you answer your questions that are related to heat. Alright? So when we are talking about conductors and insulators, what we are actually focusing on is how easy or hard heat can travel through a material. So let me just write that down for you. So when we are talking about conductors and insulators, we are actually referring to how easy or hard heat can pass through a material. All right. All right, so based on this definition, some of you may be wondering, we have not yet understood what conductors and insulators are. We know that being a conductor or insulator affects how easy heat energy can pass through a material, but we don't know how being a conductor or insulator is related to this. So now let me explain to you. So firstly, conductors, they allow heat to pass through easily. So remember, conductors, heat can pass through them easily. So this is why you realize that your frying pans are actually made up of metal, which is a conductor. So you see this metal part over here. The reason why it is made up of a conductor is so that it can heat up quickly so that you can cook your food. So from your fire source over here, heat energy is traveling to the metal surface, which is the conductor, and then you have your heat gain. So since it is a conductor, it will gain heat easily. All right, it will gain heat easily, but the same thing also applies to it losing heat. So for example, this pan is hot. I'll just outline it with red to show you that it's hot. Imagine that this pan is hot and you have switched off your fire here, so there is no more fire here. So the heat from the pan would actually be lost to the surrounding. So because it is a conductor and it allows heat energy to pass through it easily, it can also lose the heat easily. All right, so it can gain heat easily. It can also lose heat easily. So you see here, the frying pan has gained heat from the fire and then it will lose heat to the surrounding. So when we're doing the topic of heat, we always need to be aware what is gaining heat, where is it gaining that heat from, where is it losing that heat from. So these are very important questions that I want you to remember when you're doing these questions. All right, so moving on, we've known about conductors. Now we are talking about insulators. Okay, insulators. So insulators are the opposite of conductors. They do not allow heat to pass through them easily, and just like conductors, they do not allow heat to escape easily. All right, so this is an example that I have of an insulator. All right, so let me just erase all this first. So you are going to a family picnic and you want to keep your drinks cool. Why is it that you use this cooler box over here? One, with the knowledge that we've gained about materials and materials which are insulators of heat, we learned that since this is made out of an insulator, heat energy from the surrounding cannot pass through this material easily. And since it cannot pass through this material easily, your drinks will not gain heat as fast. Therefore, they remain cooler longer. Alright, so remember, when we're talking about conductors and insulators, it is how easy or difficult they allow heat to pass through them. Alright, so we have this conductors and insulators. Alright, so moving on to the final section about materials and heat, we have this picture here. So this picture is actually a train track, and you would notice that there is a gap in between these two train tracks here. The reason why there is this gap between these two rails is that when materials are heated, they expand, and when they lose heat, they contract. So this space over here is to allow a space for the rails to fill up in the event that they expand during a very hot day. If there is no gap, the rails may bend and damage itself. Alright, so this is the basics of materials and heat. So there are three things for you to know to test yourself. Can you explain what a conductor is? Can you explain what an insulator is? And can you explain what happens to materials when they are heated or when they are cooled? Alright, so we will move on to the next section of the video, which will be in another video.